All right, page 164, phases and eclipses. All right. One night, my mom, dad, and I were coming home from eating dinner. When we got out of the car, we saw that the moon was turning red. We looked at the moon for a while. Then our neighbor called and said it was a lunar eclipse. It was an amazing sight. So think about your own experiences as you answer this next question. What is the most interesting or unusual event you have ever seen in the sky? All right, what causes the moon's phases? Have you ever been kept awake by bright moonlight? The light streaming through your window actually comes from the sun. The moon does not shine with its own light. Instead, it reflects light from the sun. When the moon is full, this light may be bright enough to read by, but at other times the moon is just a thin crescent in the sky. The different shapes of the moon you see from Earth are called phases. Phases are caused by the motions of the moon around Earth. All right, so let's talk about those motions. When you look up at the moon, you may see what looks like a face. What you are really seeing is a pattern of light colored and dark colored areas on the moon's surface that just happens to look like a face. Oddly, this pattern never seems to move. The same side of the moon, the near side, always faces Earth. The far side of the moon always faces away from Earth. Why? The answer has to do with the moon's motions. Like Earth, the moon moves through space in two ways. The moon revolves around Earth and also rotates on its own axis. The moon rotates once on its axis in the same time that it takes to revolve once around Earth. Thus, a day on the moon is the same length as a month on Earth. For this reason, the same side of the moon always faces Earth, as you can see in Figure 1. As the moon orbits Earth, the relative positions of the moon and Earth and Sun change. The changing relative positions of the moon, Earth, and Sun cause the phases of the moon. All right, the moon's motion. The diagram shows the moon's rotation and revolution. Infer. Find the face on the rightmost view of the moon. Draw the face as it would appear on each view. How would the moon appear from Earth if the moon did not rotate? So for this one, there's a face here. They're wanting you to draw that same face, the nose and the mouth coming off the moon, on each of these the way you think it would be based on its spot in its rotation. And then the challenge would be, how would the moon appear from Earth if the moon did not rotate? All right, phases of the moon. Half the moon is almost always in sunlight, but since the moon orbits Earth, you see it from different angles. The sequence of events you see depends on how much of the sunlit side of the moon faces Earth. Look at the diagram on the right. During the new moon phase, the side of the moon facing Earth is not lit. As the moon orbits Earth, you see more of the lit side until you see all of it, or the full moon. As time goes on, you see less of the lit side. About 29.5 days after the last new moon, a new moon occurs again. Use Figure 2 to explore these events. All right, so describe a way to model the moon's phases using items you might have at home. Then you're going to use Figure 2 and these moons. As the moon revolves around Earth, the amount of the moon's surface that is lit remains the same. The part of the lit surface that can be seen from Earth changes. So match each photo to its phase shown on the diagram. Write the number of the phase. So you're going to use this picture and the different phases of the moon you see, and you're going to use those numbers to match to these moons, and you just need to write your numbers on that line. All right, what are eclipses? The moon's orbit around Earth is slightly tilted with respect to Earth's orbit around the sun. As a result, the moon travels above and below Earth's orbit, but on rare occasions, Earth, the moon, and the sun line up. When an object in space comes between the sun and a third object, it casts a shadow on that object, causing an eclipse to take place. There are two types of eclipses, solar eclipses and lunar eclipses. The words solar and lunar come from the Latin words for sun and moon. All right, so solar eclipses. During a new moon, the moon lies between Earth and the sun. A solar eclipse occurs when the moon passes directly between Earth and sun, blocking sunlight from Earth. The moon's shadow then hits the Earth. Total solar eclipses. The very darkest part of the moon's shadow is the umbra. You can see how the umbra strikes Earth in Figure 3. Within the umbra, the sun's light is completely blocked. Only people within the umbra experience a total solar eclipse. During a total solar eclipse, the sky grows as dark as night, the air gets cool, and the sky becomes an eerie color. You can see the stars and the solar corona, which is the faint outer atmosphere of the sun. Then you have a partial solar eclipse. The moon casts another part of its shadow that is less dark than the umbra. This larger part of the shadow is called the penumbra. In the penumbra, part of the sun is visible from Earth. During a solar eclipse, people in the penumbra see only a partial eclipse. All right, so for Figure 3, the diagram shows the moon's penumbra and umbra during an eclipse. It is not drawn to scale. Mark an X to show where a total solar eclipse would be visible. Circle the area in which a partial solar eclipse would be visible. All right, lunar eclipses. During most months, the moon moves near Earth's shadow, but not quite into it. A lunar eclipse occurs at a full moon when Earth is directly between the moon and the sun. You can see a lunar eclipse in Figure 4. During a lunar eclipse, Earth blocks sunlight from reaching the moon. Lunar eclipses occur only when there is a full moon because the moon is closest to Earth's shadow at that time. All right, then you have total lunar eclipses. Like the moon's shadow in a solar eclipse, Earth's shadow has an umbra and a penumbra. When the moon is in Earth's umbra, you see a total lunar eclipse. Unlike a total solar eclipse, a total lunar eclipse can be seen anywhere on Earth that the moon is visible. So you are more likely to see a total lunar eclipse than a total solar eclipse. Partial lunar eclipses. For most lunar eclipses, Earth, the moon, and the sun are not quite in line, and only a partial lunar eclipse results. A partial lunar eclipse occurs when the moon passes partly into the umbra of Earth's shadow. The edge of the umbra appears blurry, and you can watch it pass across the moon for 2 or 3 hours. All right, so mark an X on the photograph above that shows a total eclipse. And then here, for Figure 4, as the moon moves through Earth's shadow, total and partial eclipses occur. This diagram is not to scale. Draw a circle labeled T to show where the moon would be during a total eclipse. Draw 2 circles labeled P to show 2 places the moon could be during a partial eclipse. So you're going to do that here. All right, seasons and shadows. How do Earth, the moon, and the sun interact? Look at the diagram below. Identify what season it is in the northern hemisphere, what the phase of the moon is, and what kind of eclipse, if any, could occur. So you're going to look at this diagram. You have the sun, the moon, and the Earth. Tell me the season, the moon phase, and if there is an eclipse, what kind it would be. So use the above diagram as a model. Draw the arrangement of Earth, the moon, and the sun during a total lunar eclipse in December. So after you find this answer, you're going to compare it and you're going to design your own, and it has to meet these qualifications. All right, number 1, for assess your understanding. A solar eclipse occurs when Earth passes into a full or new moon shadow. You've got to figure it out. A lunar eclipse occurs when a full or new moon passes into Earth's shadow. So figure out which one of that is, and then you circle the right word. All right, summarize. How do Earth, the moon, and the sun interact?